All right, we're back. The reason I stopped, the other video is short. This is going to require some thinking. This is basic chemistry, and what you cover in biology, you cover how atoms work, the basic parts of an atom, the different kinds of bonds, which actually, the bonding is really important when you go to study different things, especially the stuff we're going to talk about later. So I am on page 7 of the outline. So here are elements. I showed you that. They're the periodic table. Atoms are the smallest unit of an element. And then atoms are composed of what are called subatomic particles. So you're going to have to know how to, okay, what's a proton, what's a neutron, what is an electron, and then figure out how many electrons, how are they distributed. And that's not that bad, but I wanted to say make sure I'm trying to keep these videos short, and I'd rather do 3 or 4 short ones than one long one. So starting here first, here's our atom model. Now I've given you, here's one on the one PowerPoint. I gave you a couple of PowerPoints. Here's the other one that's all filled in. So I'm going to bounce back and forth, and I'm going to show you a couple of animated parts as well. So an atom is made of 3 what are called subatomic particles: neutrons, protons, and electrons. Now I can write this here. I don't think it'll go too much. A neutron is a particle in the nucleus, and it has no charge. Hence the word neutron. They're neutral. And they're found, this is the nucleus of an atom, and they're actually represented by these gray circles here. There's 4 neutrons in this atom. Protons, and I'm going to bring this back up. A proton has a positive charge, like it says here. So it's also inside the nucleus, and it has a positive charge. Atoms in their natural state, overall they have no charge. So what that means is here are 3 little pink guys with 3 protons. Atoms in their natural state are going to have 3 electrons. That's just how it works. Sometimes there are situations where these electrons will actually move out of these shells and join with other atoms. That's where you get bonds. And then it's a whole different story with as far as the balance. But atoms in their natural state, they have the same number of protons as electrons. So that represents here. Now, electrons, I can make this a little higher up, they are the smallest of the particles. Okay, they orbit around the nucleus of an atom, and they have a negative charge. So that's why atoms in their natural state, they really have no overall charge, because they have 3 negatives and 3 positives. Sometimes you're going to have a situation which is what an ion is, or an electrolyte, where atoms will lose or gain electrons, and then they'll have a positive or negative charge. So the first 3 things right there, you're going to have to know, what is a proton, what charge does it carry, what's an electron, and like I said, they orbit around the nucleus just like this. So there's a picture. That one's not labeled, and this one is. See the pluses, the zeros, and there's the negatives. Okay. Going down a little further, the atomic number. So like I said, this is basic chemistry. The atomic number is the number of protons in the nucleus of an atom. So in this case, the atomic number of this guy here is 3. It's got 3 protons. The mass number is the number of protons plus the number of neutrons. So you add the 2 together. So here are 3 protons, and then you have 1, 2, 3, 4 neutrons. So the mass number of this atom is going to be 7. You add the 3 together and the 4 together. That's pretty easy. That's basic chemistry. I am going to post this little periodic table for you guys to see. I like it because it's interactive, but I'm going to click on oxygen up here. Here are some facts about oxygen, the element. See the 8, that represents the atomic number. See this? This is the mass number. So if it's got 8 protons, it's got 8 neutrons. And that's some basic chemistry. You have to know how to figure that out too. If you're given an example, oxygen has an atomic number of 8. How many protons are in the nucleus? Or vice versa. Do one more. Here's carbon, which we are huge amounts of that as well. See the 6? Means it has 6 protons, which means it also has 6 electrons. And then there's the mass number, and that's an exact. So the technology's gotten so well they can actually get the exact number to the decimal point. So it's 12.01. All right, and that's some basic atom, anatomy, I guess you could say. So one more thing, I'm gonna go back to my browser. Jiffy.com is great, but here's an atom. See, here's the nucleus, and it's magnesium. There's the atomic number, and over here it says 24.3. That seems to be the atomic weight or the mass number. And you can see the the electrons are orbiting the nucleus. And here's one thing you really want to pay attention to. Here's 2 electrons, and the number is 12. You see in the outermost, which actually is called the valence shell, the outermost ring, you see there's 2 electrons in there, and if you counted these up, if you get bored, there should be 8 in the second ring, which 2, 8, and 2 would be a total of 12. So that's the other thing you have to do. You have to be able to figure out how are the electrons distributed within an atom model. Here's carbon. Remember I just showed you that. It said it had an atomic number of 6, so it's got 1, 2, 3, 4, 5. Well, there's 6 right there, electrons. It's got 2 in the first shell, 4 in the outer shells. Here's nitrogen. Here's oxygen. I believe it was 8. So there's 2 and then 6 out here. But that's how bonds form. Atoms always they crave stability, and if they have full outer shells, they're more stable. And that's why these will mix and match sometimes and exchange electrons. Now, as far as bonding goes, it does have to do with how the electrons interact with other atoms. But I wanted to get down to this. All right, so here's a little formula you can use if you want. N represents the shell number. This is squared and then times 2. So, going back to our example, no matter how big the atoms are, and there's always an exception, they call those butt monkeys, okay? There's always, this is how things are, but there's this one little exception. There are always exceptions, but regardless of how big an atom is, there is a hierarchy with how these shells fill up with electrons. And the first shell can hold a max of 2 electrons. Just for time's sake, I'm not going to type out electrons. But if you want to use this formula, you put a 1 where the N is. 1 squared is 1. Then times 2 would be 2. The second shell, you could put a 2 right there. 2 squared is 4. Times 2 is 8. So, and I can't see. There we go. Anyway, the second shell, no matter how big they are, can hold a max of 8 electrons. So what happens is, if you happen to be asked, you have an example, an atom has an atomic number of 12. How many electrons are in the outermost shell? Well, if you know the first one holds 2, and then the second one can hold a max of 8, then you know there's 2 in the outside. You just kind of fill them up as you go. This one can hold a max of 18, and see if you put a 3 here. 3 squared is 9 times 2 is 18. Whew, we got big here. 4, you put a 4 in this formula. 4 squared is 16 times 2 would be 32. I'm getting a little big here. I don't want to get this big. A fifth shell, if you put a 5 here, 5 squared is 25 times 2 would be 50. Okay, good. Not going to get this big. But that's sort of the hierarchy. It doesn't matter how big the atoms are. And in this periodic table, you can see here are the atomic numbers, which represents protons. And like I said, atoms in their natural state, and these are all made of identical atoms, all these elements, they're going to have the same number of electrons. This is lawrencium. It has an atomic number of 103, which means it has 103 electrons. And there's the mass number of 262. So this is going to be a big atom. Regardless, the first orbital or shell of the atoms of lawrencium is going to hold 2. The second shell is going to hold 8. The third shell is going to hold 18. You just keep filling them up until you get all of the electrons full. And this is going to be a pretty big one. Not going to give you one that big. So, and I clicked the wrong button there. So that's how you figure out what's called the electron distribution. And I'm going to finish with this. Atoms with complete outer shells, they are more stable. If they have complete shells, and there's the mass number. Let me go back over here. Well, anyway, it goes right into the bonding, but atoms with complete outer shells, they cannot react with other atoms. This is neon, has an atomic number of 10, which means it has 10 electrons, so you'd have 2 in the first shell, 8 in the second shell. The ones with incomplete outer shells, that's a whole different story, and I'm going to start the next video with that.